LCR series and parallel. So here we got LCR board with milliammeter, 8 combinations of resistance, 4 combinations of inductance, 4 combinations of capacitance, and a function generator from 20 Hz to 2 MHz. This is Hertz, kilohertz, megahertz. So this is the frequency variation, this is DC offset, this is amplitude, attenuation, in impedance, and this is symmetric and variation. But in functionator we require only this frequency ranging selection pot and a fine frequency variable pot, and a level is nothing but amplitude. So here we are keeping, initially we are keeping level maximum and output connections provided with BNC cord with cordite clips. Okay, so I am now connecting series. In series function generator given to R, C, L in series, and ammeter is connected across resistance. Okay, now I am doing series combination. So right now I am taking 1 kilohertz resistance that is given to the functionator positive, and from 1 kilohertz I am giving to capacitance 0.1 microfarad, from 0.1 microfarad to 1 millihenry, 1 millihenry to inductance to functionator negative. So across resistance I am connecting milliammeter positive, and this is negative. So here we done the connection. The connection part is done, so we have to separate these two things. So now we have to note down tabular form. Series means initially it will be 0 and a particular F0 maximum, it will be maximum, then again it will drop. So we have to note down frequency versus current meter. Okay, so with respect to frequency you can note down the current, or with respect to current you can note down the frequency. So both as per your convenience you can do. Right now I am doing with respect to current. Okay, so now I am varying it. So here you can see there is no deflection in current meter. So it's 20 Hertz. So I am going to 200 Hertz. Still no deflection. Single deflection is there, but we cannot note down the reading. So I am going directly to 2 kilohertz. So from 2 kilohertz range, so now it is 150 Hertz. So start at 0. So now I am going to 522 Hertz, 1 millihenry. You can see here the readings, 1 millihenry. Okay, so now I am going for 2 milliamps at 860 Hertz. So I have to note down in the tabular form like this: 860 Hertz, 2 millihenry. Similarly, for 1275, 3 milliamps. Okay, so now 1797 for 4 milliamps. So so this is only 2 kilohertz. So I am stopping here and go selecting for another range. So now here I am going for another range, starts from 20. Okay, for 18 millihenry it is 6 milliamps. So here you can see, if you can see here, it is coming return. See, this is the maximum frequency where we are getting. So 18.78 is a 18.60 is F0, because we are getting the frequency down. This is the peak frequency there, 18 frequency, 18.60 for peak, for combination of 1 kilohertz, 0.1 and 1 millihenry. So that is peak. We can even find out by using this formula: F0 is equal to 1 by 2 pi LC Hertz. So here we have substitute L is 1 millihenry, capacitor 0.1 millihenry, 0.1 microfarad. You will get the F0 frequency, that should be here. So that is theoretical versus practical reading will be confirmed. So again we need to go, there are more readings to get this graph as well. So I'm seeing it is coming 20 Hertz, it's finished. So I'm going for another range. So from 20 Hertz 19.66 millihenry. For 28 it is 5 milliamps. For 40 frequency 40 kilohertz it is 4 milliamps. For 56.3 kilohertz it is 3 milliamps. For 79.7 kilohertz it is 2 milliamps. 145.2 kilohertz it is 1 milliamps. So like that we got our complete reading from 0 to maximum to minimum. This is the series connection for LCR.